This conference will now be recorded.
Alrighty, you could probably tell that I have a cold today, so our math department has decided to share the love and share a cold with everyone. So I'm the next one in line that has the cold. So hopefully you can understand me for most of this. If not, just let me know and I can type it in. Today, what we're going to be going over is a review. We have exam number 1 scheduled for this week, so I just wanted to go over the highlights of what to make sure that you're studying for the exam. And I'm also going to need to know who is going to be using ProctorU. I've sent in the proctoring form for the testing center. Apparently, the first time I sent it in, I used an old version, so that's why I think a few of you were trying to log into it, and they said that it wasn't in yet. I actually did submit it, but they wanted the updated version of it. So it's in there. It's been in there since last week. You should be able to sign up for a time at the testing center. What I need to know at this time, I want you to put it into the chat room. Are you going to be taking it at the testing center or or are you going to need ProctorU? So I know to tell ProctorU how many to expect. So if you can type your response in to the chat center, either say testing center or ProctorU, so I know. So if you can do that at this time. This is great. Thank you. Okay, so it looks like I don't have quite anyone yet for ProctorU, which is fine. I mean, I just wanted to make sure I have it all set up. If you have not yet set up your time at the testing center, which looks like everyone is interested in, please make sure you do that once we're done with our class today, because you want to make sure you get a time. Please also keep in mind that not all IB Tech sites have Saturday hours. So you want to make sure that if one of your sites doesn't, you might want to go to maybe a next site over or something like that. Or like I said, your next option is ProctorU. So also a reminder, when you do go there, you're going to need to have some sort of a picture ID. So either your driver's license or your state ID is needed. You will be allowed to use either a regular standard calculator or a scientific calculator, which are, like those $10 calculators, or the standard ones you can actually, they're even less money. You are not allowed to use a graphing calculator, and they will be checking for that. So please keep that in mind. If you're not sure, the graphing calculators are those really silly, expensive ones. They're over $100. So unfortunately, we're just not allowed to use those. So keep that in mind. Also, you are going to be given a piece of, or a few number of pieces of scrap paper. I can give you partial credit for some of the answers. So what you want to do is, when you're working out the problems, make sure you put the number of the problem next to your work. So if for some reason you got it wrong, I can go back and look at your work, and if it's on the right track, and maybe you just put a wrong number into your calculator, or you had the right answer on the paper, but for some reason you flip-flop the numbers when you were entering them, and then I can give you credit for things like that. Okay, so they will take the scrap paper, they're going to scan it to me, and they're going to email it to me. So I just want everyone to know that I grade every single one of these tests by hand. It's just an electronic version. So if you think that you entered and it was just a formatting error, don't worry about it. Because I know sometimes the WebWorks can be picky. Don't worry about that. As long as the answer is correct, you'll get credit for it. So the one thing I want to remind you, though, is watch your rounding and watch significant figures. All right, so if it does say in the problem to round it to the nearest tenth, or round to 6 decimal places or something like that, you need to make sure that that's where you've rounded it to. Because in those instances where it says to actually round to a certain number, I have to be very picky about those. So just be careful with those. Okay. So if you haven't had the opportunity to do so yet, what I'd like you to do, and that's why I've got this open on our main page here, I want you to make sure, because this is a graded assignment, to do the review for exam number 1. So if we go into module 3 where it says for exam 1, yours might look slightly different because I do have the teacher version up here. You're going to go over here, and underneath module 3, you're going to see you have some items here. Review quiz exam 1 is going to show up. Now, I purposely did not go into the student view because otherwise I can't log into it because it doesn't think I'm a student. So you're going to get a link that looks like this. So notice it's not due for a few days. And what's going to happen is you want to make sure that you do this. And then on the last available test day, which is going to be Saturday, excuse me, I will go into the program then and see what everyone's score is. And then I will be entering that score in there. Now I have left it open, or I will make sure that it is open until the end of the semester, this link. So you can always go back and redo some of the problems or practice again, because our final exam is also going to have a little bit of comprehensive review. So just a reminder, our last exam is worth a little bit more, which means that there's going to be about 1/3 review material and about 2/3 of it is going to be Unit 3 material. So you can go back. But I do take a screenshot of everyone's grades, so if anyone has any questions about it, I'll have that. All right, so you're going to go over here, and what's going to happen is you do have to press the link. It is going to take you to another site, and it's going to look a little different. It's going to say outcomes over here. And so notice there's 20 questions. It's worth 100 points, and it does give you a time limit of 75 minutes. Okay, so excuse me. It does want you to work at a pretty good pace because the exam is going to be timed. You will get 90 minutes on the actual exam, and there's going to be a little bit more problems though. But this is kind of comparable, 20 questions to 75 minutes. What I would recommend is that you do it and then go back and see which problems did you get wrong. The problems you got wrong, you can go back, review the material, take the quiz again. All right. And then see if the things that you got wrong, the topics that you got wrong, did you get it right this next time? Okay. This is meant to be done over and over again to help you practice. The problems are very similar to the homework problems, which are very similar to the problems that are going to be on the exam. So that's why this is an excellent preparation for the exam. I can tell you that I've been monitoring the results of students, what they do on these practice tests compared to what they do on the actual exam, and they're very closely related. So say you got an 80% on the practice, honestly, I've been having students get anywhere between 78 and 82 on the actual exam. So they're very, very closely related. So please don't ignore this practice exam, and it is a graded, so I have to post that in there. Okay, so you know, you could do this multiple times. So I just wanted to make sure everyone knows where that's at, and then when you do go to your testing center, the test is password protected, so your testing center will have the password that they'll have to put in to log into your exam. Okay, so make sure this week you're going to be working on the review quiz for exam 1, and then whenever you've got your exam scheduled, that is going to be exam number 1 here. Alrighty, so I want to go over, like I said, the highlights of what to make sure you know from each section. So I'm going to start with section 2. So it's just sections 2, 3, 4, 5, 6. That's the material that's going to be included in there. If you notice that in this particular case, section 2 dealt with ratios, And just a reminder, it is a comparison of relative size of, two amounts. So you see that we did some of these example problems. A ratio can be written in multiple ways. The most popular way that we write a ratio is with the word per in between, which means division, or in other words, we set up a fraction. So if it says a 3/2, that's a 3 divided by 2 ratio. Now, if they're asking you to write a ratio in a problem or they compare using a ratio, they'll tell you the order of how to write it. So if we look in this case, 1 hour to 100 minutes. So it's telling you the correct way to put it. So hour is going to be my numerator, 100 minutes will be my denominator. But if we're looking at this, these do not have the same units. The thing about a straight ratio is the units wind up canceling each other out so that we get a decimal equivalent at the end. So what we're going to have to do in some cases is pay attention to the units, and we might have to, excuse me, we might have to do a conversion. So we know in this case we have 100 minutes. Well, we know 1 hour is the same thing as 60 minutes. So let's keep everything in minutes. So that would be 60 minutes per or to 100 minutes. So it's 60 minutes numerator, 100 minutes denominator. The units will cancel out. If it asks you to reduce to a lowest term, remember how to reduce your fractions to lowest terms. And if it asks you what is the ratio, that means they want you to actually calculate it out into a decimal. All right, so so over here, then you can see what that decimal would be a 0.6. Now, what does that decimal mean? Remember, the decimal equivalent always means so many of the numerator per one of the denominator. Because think about it, if I had to put that decimal into fraction form, it would be 0.6 over 1, right? So that means 0.6 hours to 100. Or I'm sorry, hours per 1 minute. Okay, so that's what they're talking about. So always remember that. The next thing you want to make sure, how would we do some of these types of problems? So here's just an example. I underlined the part here, so it is showing us the way that you would write your ratio. Remember, just pay attention. It's going to say the way they want it compared. Okay, well, the first item is the numerator. The second item is the denominator. Once I get that decimal equivalent, what does it mean? All right, so if I use the fraction, reducing it to lowest terms, we could say Jane makes 7/8 of what Lee does. Or if I take it into the decimal format and we're talking money, that would be what, about 87.5 cents, which is about 88 cents. So for every dollar that Lee makes, Jane only makes about 88 cents. So that's another way of saying it. Or if I were to convert this into a percent, we could say Jane makes 87.5% of what Lee does. Because really, if she's only making about approximately 88 cents for every dollar, it means the same thing as about that, the percent of what he makes. Okay, so the other thing to remember is we had two different kinds of ratios. We had a part to part and a part to whole. Whenever we're comparing something to the whole lot, that is the only time that we can actually say that our decimal equivalent, let's turn that into a percent. Okay, so in this case, if I were just comparing men to women, that would be a part to part. If I were comparing, in this case, it said men to the whole class or women to the whole class, that's the part out of the whole. So that case, it would make sense in putting the percent of that in there. Okay, so remember, a part to whole is the only time that we can put the answer into the form of a percent. And then we had the other kinds of let me see here, over here, the other kind of ratios here. So when we're talking about age dependency ratios, remember it's basically divided up into three main areas. We've got children, which are considered 14 and under. We've got the working class, which is 15 to 64. And then we've got the elderly or the senior citizens. And so that would be 65 and older. So if I want to see dependency ratios, we always have to compare who's dependent and who's supporting those people. It's the workers. So our workers always have to be in the denominator there. So when we're looking over here and we're saying find the child dependency ratio, we're going to take the number of children, that's that under 14, to the working people. Okay, so remember we would set that up as long as we're dealing with numbers that have the same units. And remember these over here, these were all in the thousands. So since they were all in the thousands, because that's what it says here in the graphic, we can use the abbreviated version of the number. Okay, find the decimal equivalent. What does that decimal equivalent mean? So it means 0.3 or 0.304. In other words, there's approximately 0.3 children for every one worker, okay? Or if you wanted to make this number make a little bit more sense, sometimes, like in this case, to say, let's multiply by 100. What if we multiply my numerator and denominator by 100? Because this means 0.304 per 1. If I multiply both numerator and denominator by 100, that's going to move the decimal over 2 places, which is approximately 30 children dependent per 100 workers. That makes a little bit more sense when we talk about it that way. All right, but for the most part, either way would be a valid statement as long as your statement makes sense. Okay, and then old age dependency, remember you're going to take the senior citizens, divide it by the workers, and then any age, and when they just say age dependency, that's any age that is dependent. So we're going to add the children and the senior citizens, and who are they dependent upon? The workers. So the workers is in that denominator there. Okay, and that's pretty much section 1, or sorry, section 2. Section 3, just a reminder, make sure you understand some of the abbreviations for powers of 10 when we're converting numbers into scientific notation, because it does make our life a little bit easier. And also watch out, just because a number is multiplied by a power of 10 doesn't necessarily mean it's in the correct scientific notation form. So in this case, remember scientific notation form, step number 1, you're going to have to replace the decimal. Okay, and it says so there's one non-digit number in front of the decimal. In other words, you've turned it into a new number between 1 and 10. That's an easier way to remember that. You remember 3 is not a 0 in front of the decimal, so that makes sense with the definition. And then times the whatever corresponding power of 10. And remember, the power of 10 means, okay, how many places would I need to move to decimal to get back to the original number, and in which direction? If it's a large number, I want to get back to my decimal my exponent, sorry about that, is going to be a positive value. If it's a very small number, less than 1, my exponent will be negative. Okay, be careful with that. Remember your significant figures when you're going to be writing something out. Be careful. This answer right here, 0.86 times 10 to the 6th power, just because we've got a number multiplied by a power of 10 doesn't mean it's in correct scientific notation form. If they're actually asking you what is it in its scientific notation form, you have to replace the decimal and adjust the power accordingly. Okay, so be careful with those. All right, and then how do I go back to standard notation? So just follow the directions. Say it says move the decimal 5 places to the right because that's in the positive direction. And here's our standard form. Okay, multiplying and dividing. So remember when we're looking at this, we pulled that page out from that reference page about significant figures and how to work with this. So when I am multiplying numbers in scientific notation, first do the decimals first, multiply those, then multiply your powers of 10 for multiplication. When I'm multiplying with the same base number, the rules tell me the exponents you would add. So that would be 9 plus 5, which is 14. Now, make sure you're putting it into the correct scientific notation form because this isn't it, and that you're following the correct number of significant figures. If I have a 3-digit number times a 2-digit number, remember we always will use the least significant number of digits. So my answer has to only have 2 digits in it. And that's why when we move the decimal back 1 space, that means our exponent moved to 15, and I can only have 2 decimal places, and that's why we have 3.7. Now be careful if you have to round a number or not, because rounding does count when you're putting down your significant figures here. When we're dividing, do the decimals first, divide the first number, divide it by the second, and then remember the order is going to be the numerator minus the denominator for those exponents. And it does make a difference, especially if you've got positive and negative values there. Okay, and watch your significant figures. Let's see what else is in this section here that I can remember. So in this particular case, I've got a number 1.3 billion. And how much money would that be for each person? So that means I'm going to divide by the population, which is 300 million. So notice in this case, I've got millions and billions. That means I cannot use the abbreviated version of the number. I'm going to have to put in this particular case, in scientific notation. Now, it would be okay in this case, billion means 10 to the 9th, and this is already a nice number between 1 and 10. Okay, so we can put it times 10 to the 9th. And this one they actually put into the correct form of scientific notation, but technically you could have said, well, 300 million is 10 to the 6th. So you actually could have left it as 300 times 10 to the 6th. And then what they did is they converted it into the proper format. So you can use the abbreviated version while you're doing the examples if it doesn't tell you first to put it into scientific notation. The thing is, at the very end, you want to make sure that you have it in the correct format. Now, in this case, they're asking how much money would each person win, and they're talking money. And now money, since the number here is 4.3, you wouldn't say $4.3. It's $4.30. So watch your units. When we're talking money, make sure you put the pennies there also. If there's no pennies, put a 0. All right, put the proper format of money. Okay, remember per capita means per person. So when we were looking at the number of Skittles per person made, these had the same units, so I could just use the numbers. And this means approximately. Remember, a squiggly line or squiggly equal sign means approximately, or you can write the word approximately and in here. All righty. Let me see what else I've got. Okay, here's our other scientific notation with numbers that are less than 1. Per capita, remember, means per person. So in this case, when we were looking at the number of Starbucks locations, and here's the population, remember, I'm not going to just divide these numbers because this population says these are in the millions. So I have to make sure I either say 35,200,000 or use scientific notation. In this particular case, usually they'll tell you, like in the homework, how many decimal places to go out. All right, and then that's all the decimals they want. And then convert it to your scientific notation. And then it says how many Starbucks per 100,000 people. Well, how do I know that? It's not just this part of the answer. That means I'm going to take the decimal equivalent and multiply it times 100,000 in this case. And it just so happened that it looks like this number. Okay, so notice in this case, it doesn't look like this number, okay, because it was a little bit different. All right, so remember to convert to 100,000, or 10,000 or whatever, if it tells you how many per a certain number, multiply that number times the decimal equivalent, and that will give you that answer. Okay. And then we went over proportions. So typically what we've been doing in this case is we see what are the two things we're comparing. In this case, it was inches and miles. As long as you set up the other side of the proportion in the same way, that's what we're looking for. Okay, and then we do our cross multiplication. And I typically start, if I'm going to write out the steps, start with the one with the x here, and you can see I said 6x is equal to, and then 160 times 4.5. Essentially, what we're going to do, if we look at the steps here, is I'm multiplying the two numbers across from one another, diagonal, and then I'm going to divide with the one diagonal from the x. And so really, to solve a proportion, it's basically the same way every time. Multiply the two numbers diagonal and divide with the one diagonal from the x. Okay, and here's what it looks like algebraically, step by step. But that's basically what we're doing. Okay, so don't forget to review how to set up your proportion. And then remember, we can also use proportions to answer questions, or we can do some comparisons. Okay, let's see. These are just practice problems. Okay, so that was that in a nutshell. So more practice with application of per capita and proportion. This is where it came in, and it says, okay, here's some information that we have on the states and how much they spend on education. Here's the population of these Midwest states. Now, what if I were going to compare and do a what if scenario? All right, so if they're looking to compare a what if, they're looking for you to set up a proportion and compare something. In this case, it's saying, here's what Illinois spends, and here's their population. With a population of 6.6 million in Indiana, what would be the expected value of their expenditures if the two states were proportional? So they're basically saying, what if Indiana spent the same amount as Illinois? So if they're saying, what if for Indiana, that's the one I'm going to have the X on. Since they're comparing it to Illinois, that means I use all of their information. And it doesn't matter what order you set something up in, as long as the other side of the proportion matches. Okay, so just a review of that. Make sure you understand those what if scenarios there. Remember when we talked about the GDP, that's the gross domestic product, and per capita means per person. Okay. Then we talked about budgets. Remember, income is anything that comes in as money. Expenses are anything that you're using that money for. Surplus means at the end of a period, like at the end of the month or the year or whatever, you will have extra money left over. A deficit means you're short that amount of money. Now, if we have extra money, we can put it into savings, and a debt is where you have accumulative deficits. And we talked about the federal government, and here's just some different things for a budget. We talked about, in this case, what would be the deficit we found was it's a negative value, which means it's a deficit. 0.66 trillion is the same thing as 660 billion. So remember, if I have no full trillions, I go to the next unit down. Okay, now here's one of those where if we're comparing, so here's what the government is spending. If we compare it, and what would that be like for the person who's equivalent, the average citizen? So with the government overspending, that would be equivalent to a person who makes over 46,000 spending over 55,000. Okay, so it kind of puts it in a little bit of perspective since we're dealing with numbers that are so large with the federal government. When you put it into a little bit of perspective based on yourself, it makes a little more sense. Okay, remember the graphics. Be careful with these. Don't tell me that the first graph is the deficit and surplus and the second graph is the debt accumulated. All you did was tell me what the titles or what these graphs are showing me. Don't put the titles. If it asks you to compare or contrast something like a graphic or something in there, which a lot of times you see problems like this, what you want to do is first look at the two graphs, understand what they're about, look at all the units and everything. Now, how could they possibly be the same or how could they possibly be different? That's what you're looking for. All right. Do not just explain what each graph is showing. All right. If you do that, there'll be no points at all. Okay. Because I know what the titles are. Okay. So be careful with that. Always look. If I had to explain it, what does that mean? We're looking for a more in-depth explanation. Okay. Let me see. Consumer price index has to do with inflation. Remember, inflation is the rise of goods and services over time. So we can use the CPI value. That's a list, a number based on a representative basket of goods and services. And we can calculate like we did here. If a McDonald's hamburger costs 38 cents in 1979, and we're using the second version here, so here's the cost of the hamburger over the CPI, what would be the cost of the hamburger over the CPI of 2015? So do not use the year here. You're going to actually have to fill in whatever CPI value is there. Okay, so remember, don't use the year, use the CPI value. So you can figure out the cost of something in the future, or you can go backwards and figure out the cost of what something was before. So here's one of those problems. That starting salary here in 83. Here's what it would be the same equivalent in 2013. And if I go back in time, here's what it would have been in 1977. You can also use this idea of proportions and the CPI to confirm if a number is correct or not. So in this case, it says, here's what is the ratio of current minimum wage to that. Can we determine whether minimum wage kept up with inflation since 1979? Well, here's the minimum wage in 2017. What I want to do is set up a proportion and calculate if I didn't know what this value is. Let's say this was a blank, all right? How can I tell if this is a correct answer or not? Well, compare it to whatever year they're saying. So they're saying compared to 1979. So I would set that up. I'm not going to be doing subtractions here. I'm not going to be setting up ratios. I have to use the CPI values, all right? Because that's how we determine inflation. We have to relate it to the CPI values. So you can use the idea of the proportions to check and verify if an answer is correct. All you have to do is the one you're verifying, leave that part blank and see if you get the same answer. In this case, we actually got an answer that was more than that. We got what? We got, I think it was 8 something. Okay, I can't remember. I don't have my book in front of me, but we actually got more. So what happened in this case is the minimum wage, when we tested it, it was actually more than, so it exceeded the inflation rate. Okay, so remember, you can use that to help verify. And then I think we just had the practice problems here. Alrighty, and let's see, section 5, we talked about working with percentages. So remember we said the amount over the base is the same as the percent out of 100. A lot of times when we're thinking about statements, or can we say a statement about the information that I know, we can also say is over of for amount over base, or we could also say part out of the whole. So part is the same thing as the amount and whole is the base. Okay, so just remember, once we fill in those values, we can do that idea of cross multiplication, and you can work through the examples. We also had the equivalent of equations. It doesn't matter to me which version you use as long as you have the correct answer in the correct format. Watch your decimal places when you're converting using the equation method. In this case, you always have to convert your percent to a decimal first. All right, that's why students like the proportion method, because you don't have to do any converting of your numbers to decimals. You just put them in as is. Okay, and we had a lot of example problems here. Let me take a look here. Also remember, we do have percentages that could be over 100%. And that's usually when we see markups of goods and services. So one of the rules to think about to, kind of verify if your answer is correct is if you're using the proportion method, remember this amount always relates after you've taken that percentage. So always think about it. Is this number after I've taken the percentage, or is this the number before I took the percent? Because you might have it upside down then. Always think about that number. Also, if in this case the numerator is larger than the denominator on this side of the proportion, the same has to be true on the other side of the proportion. So that's why we had 150%, which is more than the denominator here. And then if this were smaller than the denominator, the other side would match, smaller over denominator. So that's another way of verifying if it looks like your answer might make sense or not. So I just kind of want to point those out because those usually help you. And these are just a bunch of example problems here. Alrighty, so that was just the gist of that section. And then our final section, we had descriptive statistics and weighted averages. So remember, we're basically looking at the three main mean, median, mode. Range is the difference between the highest value and the lowest value, which is the max and the minimum. Remember, mean is the same thing as the average. Add all the numbers up and divide by however many you have. Okay, can everyone hear me now?
Yes.
Okay, looked like my audio went out for a second there. All right, looks like I'm back. Okay, thanks. It looks like I was out. Okay, so just remember mean, median, and mode, the differences between the three. Remember, mode can be more than one number. Okay, and then don't forget for the median, put them in numerical order there. Also, what does it mean when something is skewed to the left or to the right, or if it's symmetrical? Remember, if something is symmetrical like this here graphically, essentially the mean and the median are the same number. They're very, very close to one another. If for some reason the mean is larger than the middle value, that median, okay, that means it would look like this. It would have a tail over to the right, and this means that the mean is so large, it's dragging some of the numbers, or the average, it's dragging that average to the right. Might not be a lot of large numbers, but there's enough large numbers that it drags that average over. And then the opposite is true when something is skewed to the left. We would have the mean is less than the median. So it really depends on where that mean is, okay? And if the mean is in the middle, the same, it's symmetrical. If the mean is less, think less is to the left. If the mean is more, more goes to the right, just like a number line. Okay, so understand if something is skewed there. And then weighted averages. Remember, there are two different kinds of weighted average. The first is the method 1. Means if they do not give you a number in a form of a percent, if they just give you how many of something, then we would use this version. So we take the value times its count and so on. And in this case, you have to divide by the total count. The most popular way we find a weighted average using the count method is a GPA. So know how to calculate a GPA. And then how would I calculate like a grade in a class in this case? So that would be using the percent method, which is method 2. So in this case, we would just take the value times its weight plus the next value times its weight and so on. And then that would be the final answer. Okay, and here's an example of that. Okay, and the weighted average is how we're going to be doing that project number 1. So you can see that there. Okay, so know the difference between the two different forms of weighted average. And, if something is weighted more, that means it's more important. So those are the categories you need to really make sure you're concentrating on. Let's see what else I've got here. Here's a question that Happy Widget Company, if I wanted to figure out the average salary, if I just took a straight average of all these salaries of the different employee levels, that's 181,000. Well, it wouldn't make sense if I'm a new employee coming in. I'm not going to make 181,000. I'm not going to just make the average salary. And that's why it would make sense to do a weighted average, since 70% of the employees are over here at level 2 making in the 60,000 range. So would I make approximately 67,000? That's more of a possibility. Okay, so that's why when we're using comparisons, sometimes it makes sense to use weighted averages rather than a straight average. Okay, and I think that's pretty much all the different topics in a nutshell that are going to be on the exam here. If anyone came late and you didn't tell me if you were going to be at the testing center or if you need ProctorU, if you already answered it, don't worry, I've got your answer written down. But if you came a little later and you didn't, can you please tell me if you're taking your exam this week in the testing center or with ProctorU? Okay, because I think I had a couple people come a little bit later. Okay, just in case you didn't answer it right away. Okay, so like I said, don't forget to do that review quiz. That's definitely going to help you. Do it multiple times. All right. Make sure you show up at the testing center ahead of time. If you show up late, there's no guarantee that they will let you in. If you can't get in, you need to let me know, because your other option is ProctorU. Yeah, ProctorU is online, and you need to make sure that if you're not going to go to a testing center, ProctorU, there's an extra fee for that. I think it's around $15. Okay, so if you're going to be using ProctorU, let me know so I can send the paperwork to them. No, don't just walk into the testing center. There's directions in there. You have to set up an appointment. Good question. You have to set up an appointment ahead of time with your testing center, and everything is done online. So you'll find that information under the, I think there's a section in the syllabus that says about proctoring, and there might be a direct link to that. Okay, yeah, good question. Yeah, don't just do a walk-in. They might not have room for you. Okay, so somebody is already set up. Okay, perfect. Okay, so the person, let me see who said. So Jessica, ProctorU online. Oh, Jessica, you're going to the Gary Testing Center. Okay, that's great. It needs to be taken no later than Saturday evening, and keep in mind that not all testing centers are open on Saturdays. But for those people who the only option is ProctorU, that's why I leave it open on Saturday. But there are a few testing centers that are open on Saturdays. Okay, so like I did announce earlier, make sure that as soon as we're done here, if you haven't had the opportunity yet to schedule your exam, soon as we log off, do that. Schedule the exam so you get the time you want. Okay. Okay, so that is all I have for you today. I just wanted to make sure I went over the highlights of what you need to make sure you understand for the exam, and just kind of point out, you know, how to properly answer some things. Okay, remember, you're going to be given a scrap paper. Just number the problems on there, because I can give partial credit in some cases. Okay. So I'll stick on the line if anyone has any other questions. If not, you are free to go, and good luck with your exam this week. So unless it, for the exam one discussion, is it the same? If it says that, but I think exam one discussion is more, there's like a pre and a post, I think, that talks about it. So how are you getting ready for the exam? And then later on, you know, did you learn anything by that? So whatever it says, I honestly can't remember if it tells you to respond to two other people. If it doesn't specifically say that, then no, you don't have to. I honestly can't remember, because I'm teaching a few different sections of online classes, and some say yes, some say no. Okay, I have just a couple of you out there. Are there any other questions that you need answered? Okay, if you have no other questions, then I'm going to be logging off. If you have anything that you need to get a hold of me, either email me or you can take a look at my office hours or you can call my office phone. But emailing is the best way to get a hold of me. Good luck on your exam.